Hello, my name is Joshua Sepulveda, and I'm going to talk about OCaml, which is a functional programming language. So, in order to dive into OCaml, we first have to understand what a functional programming is. Functional programming is a programming paradigm that treats computation as evaluation and avoids changing state and mutable data. It is based on mathematical functions and relies heavily on the principles of mathematics and lambda calculus. Functional programming has a couple of key characteristics, and a few of them that are signaled in this slide are first class and higher order functions, immutability, pure functions, and recursion. First class and higher order functions means that functions can be passed arguments to other functions, returned as values from other functions, and assigned to variables. Immutability means that data is immutable, which means that once it is created, it cannot be changed. Instead of modifying existing data, new data is created. So, for example, let's say that you have a house address, your current house address, and in that variable, you have your house number, right? We're not going to create a new line of code in which we assigned to address 1 the house number of the house that you just recently moved into. Instead, we're gonna make a new variable and declare it by using the new address number. In functional programming, you have to do it through those means. That's exactly what that means by immutability. Data created stays the same, and if there's something to be changed, the new data should be made. Pure functions. These functions always produce the same output and they have no side effects. A pure function is a function that, given the same input, it would always produce the same output. It has a side effect. A side effect could be a global variable. And then one of the most important topics about functional programming, which is recursion. Functional programming language use recursion instead of loops for repetitive tasks. Functional programming languages include Haskell, Lisp, Scheme, and OCaml. Now let's talk about OCaml. OCaml, which stands for Objective Caml, is a functional programming language with a strong emphasis on type safety and expressiveness. OCaml came to be by developers at INRIA, the French National Institute for Research in Computer Science and Automation, in the late 1990s by researchers Xavier Leroy, Jerome Bouillon, Damien Doiges, and Didier Remy. OCaml comes from a long line of research of ML, which stands for meta language. The key features of OCaml include functional programming paradigm, strong and static typing, module system, immutability and persistent data structures, bytecode compiler, and the native code compiler. Functional programming paradigm means that it treats computation as the evaluation of mathematical function and avoids of changing state of mutable data. Strong and static types provide type safety at compile times. Module systems, robust systems, are systems that allow developers to structure their code into separate modules. Immutability and persistent data structures. OCaml encourages immutability and many of its data structures are persistent, which means updates create new versions of the data structures rather than modifying the existing one. And exactly what we get back to the immutability, which means same data cannot be rewritten or updated. You have to create new data in order to store that new data. Bytecode compiler and the native code compiler. The native code compiler generates highly optimized machine code, making OCaml suitable for performance critical applications. Now let's get into one of the main points about programming languages, functional programming languages, and OCaml, which is the type system. OCaml is a language that is statically typed, which means that the variables are known at compile time. OCaml features type inference, allowing the compiler to deduce the types of variables and expressions without the explicit type. So let's look at what statically type means, which is the compiler will check for the type correctness at compile time. It helps catch potential errors early in the development process, so the debugging is made easier as it won't show when the code is fully executing. Type inferencing in terms of OCaml, it's saying let x equals 3 plus 3. There's no need to declare the variable type such as other languages such as such as Java and Python, which are imperative languages. So compared to these two languages, in Java, you have to declare the data type with the variable name. So for example, if I want an int, I will have to say int x equals 3 plus 3, or float, or long, and so on and so forth and so on. Whereas Python is more similar to OCaml, in which you don't have to specifically say what kind of data type it is. You could just name the variable and the program will do it for you. However, Python may have some errors in which you could insert a number and it'll convert it to a string. So that's why you should use type inferencing, such as putting int right before it. So instead of Python turning the variable into a string literal, it still turns it into an actual number. OCaml is strongly typed, which means that once the variable is assigned to a certain type of, it cannot be cast to another type. However, the variable can be changed with a explicit type conversion. Strong typing helps prevent unintended type-related errors. OCaml supports parametric polymorphism, allowing the defining of generic functions and data structures. That means for functions and data structures can be written to work with values of any type, providing flexibility without sacrificing type safety. By emphasizing static type, type inferencing, and strong type, OCaml's type system contributes to writing robust and reliable code. It helps catch potential errors early, promotes code clarity, and allows for the development of expressive and generic functions. Tools and ecosystem. OCaml's compiler translates OCaml source code into executable binaries. It includes a native code compiler and a bytecode compiler for portability. The native code compiler increases the speed and the program's execution for large scale problems. OCaml build and Dune. These are both build systems of OCaml that automate building processes. OPAM is a package manager for OCaml, providing a repository of OCaml libraries and tools. IDEs. OCaml has IDE supports from editors like Visual Studio Code, Atom, and Replit. I use the Visual Studio Code extensions and also had to download the virtual machine and environment for OCaml to try to code it into Visual Studio, which I used. Now let's take a look at these OCaml code snippets. So in the top left corner, we have something simple, which is variables and data types. And compared to functional programming, the way you declare a variable is by saying let x or let y. And since we have things such as type inferencing, we don't have to specifically write out what kind of variables they are. So we could use let x equals 10 in, and in means that the variable x10 is going to be used in a in a single in a specific part of the code. Same thing with y, and then if you want to use a single character, you can make a character, you can make a variable of a character by just using single quotes. On the top right corner, we have the common, most usual, and cliche aspect of programming, which is with whatever programming language you're using, you want to print out hello world. Now on the bottom left, there is a code snippet that shows us functions and higher order functions, which means that I can put in a function into a function and it'll give me out a function, and you can manipulate functions with each other. So for example, we have let square x equals x times x, which squares a number because it multiplies it times itself. Let double, which doubles a number. So whatever you want to put for an x, it'll double it. Then let apply twice, which will take a function as a parameter in order to do math, which it will give you the square of the number you just squared. So for example, if I have 3 times 3, that's 9. Now, if I want to square that and the function let apply twice, is going to be 81. Bottom right is list and tuples, which is let my list equals 1, 2, 3, 4, and then my list, and then a tuple is 5, an OCaml in which you could mix and match data types, and then you could have let concatenated list 0 add my list, which will add 0 into the list we already declared. Sort of like in other programming languages, such as Python or Java, where you have arrays or lists where you could add things by using built-in functions. OCaml code snippet. Another code snippet is this Fibonacci sequence. This is an example of recursion. Recursion is widely used in programming languages. In functional programming, recursion is used to repeat the same task, whereas in imperative programming, use loops to repeat tasks. The following code snippet shows a parallelized version of the Fibonacci sequence. Parallelized is a concept in computing where multiple tasks or processes are executed simultaneously to improve system performance, speed, and efficiency. Parallelism allows multiple tasks to be performed at the same time. There are two parts of this code. There are two Fibonacci sequence codes. One is sequential and the other one is a parallel code. The sequential one will keep adding until n is less than 20, in our case, until n is less than 2, in our case 20, so it's going to run for a couple of times. Then the parallel code will check for the numbers of the domain. If it is less than or equal to 1, it falls back to the sequential Fibonacci sequence. Otherwise, it computes a Fibonacci sequence in parallel for A, then it makes a new domain for B. The sum of both is added with domain.join. This code will tell you that Fibonacci, the 20th number in the Fibonacci sequence will be at 10,946. The good thing about this parallel code is that you are able to make this faster since you have the same code running on twice on different instances. And that's a very important thing about functional programming. Real-world applications. OCaml is a versatile language, has made its way into multiple environments, and some of these are finance, social media, and virtualization. Finance, the most prominent use of OCaml is found in Jane Street Capital, which is a financial institution that is used widely by OCaml. For example, in my paper, I read about how this researcher ended up working at Jane Street and they rewrote the entire system into OCaml. Social media. Meta has built a number of major development tools using OCaml. Virtualization. Citrix uses OCaml in Zen Server, a world-class server virtualization system. Citrix is also used by the school as a means of accessing the school computers through an external device, such as your computer, and you are able to go into the school computers through your own computer. The usage of OCaml in the finance world is prominent due to the strong typing, functional programming features, and performance characteristics that make it well suited for financial applications. The challenges and limitations that come with OCaml are few, as there's a there's a difference between an imperative language and a functional programming and then a functional programming language. Learning curve. OCaml has a learning curve, especially for developers who are new to functional programming or come from more mainstream imperative languages. Limited adoption. Compared to more mainstream languages, OCaml has a smaller community and it is less commonly used in industrial settings. Domain specificity. OCaml may not be the best choice for every type of application. Developers have to carefully evaluate if OCaml aligns with the requirements of the project. Interoperability. Integrating OCaml with other programming languages can be challenging. Community size. The size of the OCaml community is smaller compared to more widely used languages. This results in fewer third-party libraries, tutorials, and community-driven resources, making it potentially more challenging for developers to find solutions. While there are mechanisms for integrating with C and Rust, this may not always be as straightforward as in languages designed with easy interoperability in mind. For example, if you take other languages like Java, Python, C, there's tons of online support when it comes to libraries, frameworks that allow you to use these languages in a bigger scale, whereas OCaml is very limited to more mathematical, scientific, industrial slash financial applications where a lot of numbers need to be used and manipulated in a mathematical way. Conclusion. In conclusion, OCaml is a very important language based from meta language, which is based on functional programming. It has the pros and cons, and the main pros of OCaml are the functional programming principles, the syntax, type system features, tools, and real-world applications. Their strengths such as strong typing, functional programming paradigm, and its application in specific domains like finance and form verification allow it to be good in those domains. However, there's a downside as it cannot be used for many other operations as it's very limited to that type of domain. However, as a programmer, it is your job to find out what programming language is best for your applications. So you have to accommodate in order to make sure that your application or program or whatever it is that you're making on is as efficient as possible. So you have to gauge which language I have to use and which one is more suited for your application. Thank you for listening to our presentation and have a great day.